30s. This video is just going to be a continuation of lesson 8, and I'm going to be solving 2 additional class examples. So if you want to find this one in your note package, we are going to solve the second degree trig ratio. So let's bring the negative tan of x over to the left-hand side. That would give us root 3 tan squared of x plus tan of x is equal to 0. From here, I'm going to factor out a tan of x. And I would be left with, so tan of x is one of my factors, and my second factor would be root 3 tan of x plus 1. That's equal to 0. Let's set each of these factors equal to 0 and solve. I would have the tan of x is equal to 0, and over here I would have the tan of x is equal to negative 1/3. Sorry, negative 1 over root 3. Okay, so let's find on our unit circle where is the tan of x equal to 0? So remember that tan is y over x. So we're going to be looking at our coordinate points, and when we divide y by x, where will we get solutions of 0? So 0 divided by negative 1 gives us 0. So that means this would be a solution at 0 radians. Here would be undefined because 1 divided by 0 is undefined. So there is no solution over here at pi over 2. This would also be a solution. Tan of x would be 0 here because 0 divided by negative 1 is 0. So that means that pi radians is a solution. We would be undefined down here. And back at 2 pi, we would have a solution. However, 2 pi is outside of the domain restriction because we must be less than 2 pi. So the solutions where the tan of x is equal to 0 would be at 0 radians and at pi radians. In order to find the solutions where the tan of x is equal to negative 1 over root 3, I'm going to look at my cast rule, and where tan is negative is going to be in quadrant 2 and in quadrant 4. Many students know that all the x coordinates are sine, x coordinates are cos, y coordinates are sine, but you don't quite have tan memorized, which is fine. If you don't have tan memorized, we're going to find the reference angle by taking the inverse tan of the absolute value of 1 over root 3. This will give us the reference angle. So if you want to take out your calculators, make sure that you are in radian mode. And let's take the inverse tan of 1 divided by square root of 3. That gives us the reference angle of 0.523. And what I'm going to do to find the exact value, I'm going to divide that number by pi, and I'm going to math 1 fraction it. So that would give me a reference angle of 1 pi over 6, or pi over 6. So pi over 6, that is my reference angle. If I put pi over 6 in this quadrant here, the rotational angle would be 5 pi over 6. So that means that 5 pi over 6 is a solution. Then over here, if I put the reference angle of pi over 6 here, and I said, okay, what would this rotational angle be? That would be 11 pi over 6. So I've got 4 solutions, 0, pi, 5 pi over 6, and 11 pi over 6. What I have to do, though, is I have to make sure I've got to check my non-permissible values. And we do have non-permissible values here. The reason is the tan of x, remember, is a quotient identity. So the tan of x is equal to the sine of x over the cos of x. What that means is I'm going to have a non-permissible value where the cos of x cannot be equal to 0. So cos of x cannot be equal to 0. So let's find for which values would the cos of x be equal to 0. So where on these coordinate points is x 0? That would be at pi over 2 and at 3 pi over 2. My x coordinate is 0. As neither of these non-permissibles were any of these 4 solutions, it just means that these 4 solutions are valid. Okay, the next one that I want to do, or the last one I want to do, is this one here. So it gives us the sine squared x is equal to 1/2 tan of x cos of x. So you might be saying, okay, well, what would we do here? And sometimes you have to play around with different things, like is this going to be a Pythagorean identity, or what will you do? One of the things, though, it said is you need to get rid of reciprocal identities if you can. So cos of x, I can't do anything with that, but tan of x I can. So what I would have is I would have the sine squared x is equal to 1/2. Tan of x becomes the sine of x over the cos of x. And this is times by the cos of x. So what you would see at this stage here is the cos of x over cos of x would cancel. And we're going to be left with the sine squared of x is equal to, I'm going to just put actually the sine of x all over 2. Okay, I want to get rid of this denominator of 2. So what I'm going to do to get rid of that is I'm going to multiply this right-hand side by 2. What I do to the right, I must do to the left. Now I have 2 sine squared of x is equal to the sine of x. Let's bring everything to our left-hand side. And we're going to have 2 sine squared of x minus 1 is equal to 0. Okay, so what would you do from this point? So this should be minus sine of x. Let me just fix that. Okay, so from here, let's factor out a sine of x. Sorry. Factoring out a sine of x, we're going to have one of our factors as sine of x. When I divide that out, I'm going to have 2 sine of x minus 1 is equal to 0. Now we have to set each factor equal to 0 and solve. So this factor is simply going to be the sine of x is equal to 0. And the second one is going to be the sine of x is equal to 1/2. Okay, so where's the sine of x equal to 1/2? According to your cast rule, sine is positive in quadrants 1 and 2. So we're going to have 2 solutions in quadrants 1 and 2. I'm actually going to look to see if they want degrees or radians. So they want degrees for this. Remember that we're looking for where is our y value going to be 1/2. And that's going to be at pi over 6, which is 30 degrees. So 30 degrees would be a solution. And in this quadrant here, if the reference angle is 30 degrees, the rotational angle is 150 degrees. So I've got 2 solutions there. Where is the sine of x equal to 0? So now we're looking at our y coordinates on our quadrants where y is 0. So that is going to be over here and over here, which means I would have a solution at 0 degrees, at 180 degrees, back to 360 degrees. However, I'm not going to include 360 because it's not within the domain. So where the sine of x is equal to 0, it'd be at 0 degrees and at 180 degrees. So as it stands right now, I have 4 solutions. I just need to check non-permissible values. So what the non-permissible values would be the cos of x cannot be equal to 0. So where are the x coordinates 0 on my unit circle? That would be over here at 90 degrees and at 270 degrees. So that means that all 4 of these would remain solutions. So I'm just going to say x cannot be equal to 90 degrees or 270 degrees. Okay, let's verify this graphically that we do in fact have 4 solutions. So what we're going to want to do is we're going to put this on the left-hand side in y1, and we're going to input this in y2. You're going to want to make sure you're in degree mode 0 to 360. So I think I have this set up on my calculator already. We'll just double check. I'll clear this. So I'm going to go to degree mode first. I'm going to go to my window, and it was 0 to 360, and I set my scale factor at 30. And then my y min to y max, I'm just going -2 to 2. If I go to y is equal to, so here's the left-hand side of the equation with sine squared of x. So remember to enter that in a bracket because you don't want to be squaring your angle here. And then on the right-hand side, I had 1/2 tan of x times cos of x. So from here, I'm just going to graph this, and we're going to observe a couple different things. We have non-permissible values. So right here's a non-permissible, and down here. If each hatch mark is 30 degrees, this would be 90 degrees, and this would be 270 degrees. So those are the non-permissible values of cos, where cos of x cannot be equal to 0. The solutions are at any intersections. So you could check on your calculator the solutions, but we would have a solution here at 30 degrees, 150 degrees, 180 degrees, 360, which is outside of the domain, so I wouldn't include that, and there would be a solution at 0 as well. So there are 4 solutions and there are 2 non-permissibles. And that would be it for this class example.